Welcome to NIOP Chemistry. Hello, good morning students. How are you? I hope you are fine at home. Okay, please watch this program till end of this video so that you may get some more basic points. In previous video, we have learned about different states of matter. In this video, you are going to learn about different types of matter. What's the difference between states of matter and types of matter? Are you not getting any doubt? Okay, let me clarify your doubt. States of matter. One of the properties of matter we have used for classifying the matter into solid, liquid and gas. But here types of matter only we are classifying on the basis of which property I did not mention now, but types of matter only I said. Actually here types of matter is completely based on composition. Composition only give us a detailed account of the different types of matter. How can we understand this different types of matter on the basis of composition? Let us take a simple example. Sugar and sodium chloride, a table salt. Both are same. In appearance, both are same in color, both are same in state. But if we test using some other properties, then only we can come to know what substances they are. State is same, color is same, but they are different. Composition of matter only gives the weightage for particular substance. Okay, now let me take another example. Oil and water. You are familiar with these two materials. One is oil, another one is water. Both are in liquid state. Somehow for appearance also nearly same. Sometimes some water and oils also nearly same in color, appearances. So we cannot distinguish until unless we test the substances by using some of the properties of those materials. And here matter is broadly classified into pure substances and impure substances. This pure substance, how can we understand the substance in its pure state? That means it is made up of same kind of finest particle or the smallest units. In previous videos I mentioned matter is made up of tiny particles. Okay, tiny particle, maybe it is an atom or it is a molecule. So this molecule, smallest units I am mentioning here, please, not smallest particle. Smallest particle means it may go in another way. Smallest unit of a substance that gives the properties of the parent substance. For an element, atom will consider, but for some substances like compounds, we'll take smallest unit as molecule. Okay, now let us plug into the topic. Here, pure substances and impure substances. Pure substances are made up of same kind of units, and throughout the substance uniformity is there. That means homogeneous matter it is. Pure substances are always homogeneous. Distribution of the particles are equal. in all directions, whereas impure substances, they are different. They are made up of different kinds of matter, and the different kinds of matter are in different proportions. And you need to know one thing. Whenever
We say that a substance
means
is an
it's
impure.
exactly a mixture. That mixture may form by the combination of elements, by the combination of element and a compound, or by the combination of compound and compound. Different combinations we can see for a mixture. Anyhow, whatever it may be the materials that may composed of impure substances, they are just mixing each other. There is no chemical force acting between any two molecules or any two particles. Those are mixed up each other. That means chemical forces are absent, only they just interact each other. Then how can we understand that impure substance, and how can we identify or how can we test the impure substance? First, let us give a definition. Impure substances are the substances in which some other substances are also present in smaller amounts, having no chemical forces between those particles. And we can study this impure substance by studying
The
some of.
characteristic properties of the substance.
Okay, now our today's topic, pure substances. Pure substances are classified into two: elements and compounds. This is a broad classification of pure substances. Pure substances are always homogeneous. And here, elements. Let us see first the elements. How can we give a definition for element? You might have seen many substances around you, and what substances you did not see still are unnumbered. That means you have known only a drop. Unknown is an ocean. So, are unnumbered substances or materials are present. Millions substances are present. These different types of materials or substances, how they are formed, how they are made up of. That means those materials or substances are also formed by some basic materials. Those basic materials we call them as elements. We can define these elements like this. Elements are the pure substances which cannot be further divided into any simpler substances by any physical process or any chemical process. Once again, elements are the pure substances which cannot be divided further into any simpler substances by any physical process or any chemical process. Let me clarify here itself. According to this definition, one simple substance if we take, I am taking here a piece of gold. If we cut the piece of gold, some more pieces if we make into more pieces of gold, we'll have. Or if we grind it into fine powdered particles of gold, we'll have. Or instead of these gold particles, will you get any silver particles or any diamond particles? Is it possible? No. That means it is impossible for us to cut it into new substances. So what is the physical process? I applied here cutting one, and grinding is another physical process. So whatever the physical process I might have applied, I did not get any new substances. Only the substance, the parental substance, what I have taken from that, only some pieces or some particles are separated. By chemical process also we cannot separate or we cannot convert one particle into another particle. How can we understand this concept? Okay, see here some examples for chemical process. I mean, by applying chemical process, how we cannot convert one particular element into another simpler substances. For that only I have taken here two examples. So one is hydrogen reacting with oxygen and forming water, H2O. And here sodium, an element, reacting with chlorine, another element, and forming sodium chloride. Okay, what you have noticed here, we have taken hydrogen, an element, and the formed substance also contain hydrogen atom. Hydrogen not split into any other simpler substances. Here we have taken hydrogen and the formed substance also contain hydrogen. And here we have taken oxygen, the formed substance also oxygen is present. Likewise down. Sodium we have taken and here is sodium. And here chlorine, and the same chlorine also present in the formed substance sodium chloride. So it is clear that even chemical process cannot divide in a simpler substance. I mean, what substance we have taken as a simpler substance, basic materials, cannot be divided further into any other simpler substances. Okay students, here it is clear element is the simplest substance which cannot be further divided into any other simpler substances by any physical or chemical process. Elements are classified into four classes based on the similarities and dissimilarities. That means some of the properties of those elements were studied. Based on those properties, elements were categorized into four classes. First one, metals. Second one, non-metals. Third one, metalloids. Fourth one, noble gases. And here metals, I think you are familiar with at least a few metals. Iron, well known metal. Aluminium, copper, gold, silver, whatever the metal I mentioned now, definitely you might have a knowledge in this area. And some of the uses of these metals also you can come to know. Gold, silver, copper for ornamental uses and ornaments, I mean jewelry purpose they use, and iron for building materials and machinery parts, and even some grills. So different purposes they may use. Aluminium, lightweight body parts of vehicles, airbuses, and window frames. You can come to know that. At your home also you can check that window frame if you have. and lightweight body parts of some tools also you can see. The next, the most abundant elements from these metals, most abundant metal is aluminum. In earth crust, the most abundant metal, aluminum. After aluminum, iron and some other metals also. And what about other metals here? I wrote sodium and potassium. Sodium and potassium are other metals which plays vital role in our body, which are carrying some signals. Okay, and many metals are present: zinc, magnesium, calcium. Calcium gives strength to our bones. At the same time, magnesium also, and even magnesium present in red blood cells. Sorry, iron is present in red blood cells as a central atom. Magnesium, calcium present in bones. Even zinc also present in our body in smaller amounts. Don't think that other metals are not present. Actually, our body is itself a chemical factory we can compare. The next non-metals: hydrogen, oxygen, nitrogen, and chlorine, fluorine, and these are the some non-metals. So here non-metals always react with metals. Metals form positively charged particles, whereas non-metals form negatively charged particles. So both oppositely charged particles attract each other, then they form a compound substances. Generally we say compound substances formed between metals and non-metals. The next class of elements are metalloids. These metalloids in periodic table, these metalloids were placed in between metals and non-metals because these metalloids shows some properties of metals and some properties of non-metals. By this reason, these metalloids were given place in between these metals and non-metals. The next one, noble gases. Okay, let me give another point concern these metalloids. Where we are using these metalloids means only one use I will mention. In transistors or in any electronic devices will use these metalloids as conductors. Okay, the next noble gases. These are 6 in number and they are free in state. They have no chemical reaction with any other elements or any other substances also. They are stable, they have stable electronic configuration we say, and they won't react with any other elements. This is about classification of elements. Here some common elements. Let us see here some common elements in different areas in the universe, earth crust, atmosphere, and in human body. So first let us see here in the universe what elements are present in abundant. Hydrogen and helium. Actually it was the belief of some scientists. These are the 2 elements, and even these 2 elements, first one hydrogen is the primary one and basic element from which all other elements came out, or all other elements are formed. That was the belief of some scientists who believes Big Bang concept. Okay, anyhow, these are the 2 abundant elements that were noticed and present in the universe, mainly in the sun and the stars. So when when stars exploded, some other elements come out of the heart of that star. That was the belief of the scientists. Okay, now here earth crust, here oxygen, aluminum and some other mineral substances are also present, but abundant elements first from non-metals oxygen and from metals aluminum were noticed as abundant elements. The next one, atmosphere, nitrogen and oxygen, these are the major elements. Nearly 70 8% of nitrogen and 21% of oxygen are present in atmospheric air. Then next one, human body. Human body is completely made up of three elements in major proportions. It does not mean that only these three elements are makes up our body. Now the major proportions of the three elements are carbon, hydrogen and oxygen. Some another elements also takes their percentage proportions. Nearly more than 60% of our body is made up of these three. Then now compound. What are compounds? How these compounds are made up of? Okay, let us see the definition for compounds. Compounds are pure substances made up of two or more elements combined chemically in a definite proportion. Let us take an example, water. Water is a compound. What do you think? Water? Water is not an element, it's a compound. See here. Water is formed from two basic elements, hydrogen and oxygen. So here how these two elements, hydrogen and oxygen, combine to form water. What are the fixed ratios by volume and by mass? Okay, let us see here. By mass, the ratio existed between hydrogen and oxygen is 1:8, and by volume the ratio existed between hydrogen and oxygen is 2:1. How can we find out these ratios? For finding the ratios you need to know two things. For mass, you should know about the masses of elements and compound, and for volume, balanced chemical equation will help you to find out the volumes that you are taking for the formation of water. Okay, let us see here by mass. Here hydrogen, single hydrogen atom mass is equal to 1 and single oxygen atom mass is equal to 16. Now see here, in a single water molecule, hydrogen 2 atoms. That means for hydrogen 2 multiplying 1. This is the mass for hydrogen in water molecule. And now oxygen. Here only one oxygen atom is there. So only one oxygen atom, and for single oxygen atom mass is 16. So for hydrogen 2 and for oxygen 16. So take here 2:16. Then simplest ratio, 2 will go one time and 2 will go 8 times. So 1:8. How we got this simplest ratio 1:8 for hydrogen and oxygen is, this is the explanation. And next one, by volume. Okay, for finding volume, once again I am stressing this, you need to know about balanced chemical equation for a particular reaction. Then only is possible for you to get the ratio between the elements. Okay, now here you see 2 volumes of hydrogen are taken, and here no number is there. No number is there means always we take 1. So for hydrogen 2, here it is, and for oxygen 1. So 1. I think this example will make you to understand how the fixed ratio is taken by volume or by mass. For each and every chemical reaction you can apply the same. Now mixtures. Okay, what is mixture? How the mixtures are formed? Mixtures are impure substances. They are formed by components mixing with each other, and there exists no chemical force between the components. And the most important one is there exists no definite ratio. That means in indefinite ratios, any ratio, it is possible to form this mixture, and the chemical forces are not acting between the components. These are the two important points: indefinite proportion, and the second one is no chemical forces acting between the components. These are the two properties that required for you or for us to give a definition of this mixture. Let us take a simple and well known, and while going roadside, I am sorry for mentioning this example, and it is a good and well known example. While passing by the roadside, some people used to prepare some lemon juices. In that lemon juice, some people add only sugar with some salt, some people only add sugar, or some people add only salt, some people add sugar, salt together in that drink. Okay, now have you ever drink this? Okay, once try at your home. If you have lemon, first you mix it with some sugar, you taste it, you feel only sugar and lemon. If you mix that lemon juice with salt only, then you feel only lemon juice and salt taste. If you mix sugar, salt together with lemon juice, you understand the taste of sugar and salt. That means here sugar is showing its property, and salt also giving its property. Both tastes at once, you are able to see that. You will experience that once you try it. If possible, if the things are available, you can try for making this type of mixture. Okay, let me clarify here the differences between compounds and mixtures. Compounds are homogeneous, whereas mixtures are homogeneous or heterogeneous. Compounds are always made up of same kind of materials in a definite ratio. That means the main important point is definite ratio is existed between the components, whereas in mixtures there is no definite ratio. I have already mentioned this point, no definite ratio. That means indefinite ratios. Compounds cannot be separated by physical process, whereas mixtures can be separated by physical process. Only chemical process is required for the separating a compound substance. And here compound substance properties are different from the elements from which it is formed. That means elements, for example hydrogen, oxygen are the two elements. They are combining to form water. Water has new properties. Don't think that hydrogen is present in water, so hydrogen shows its properties. No, it won't show. And oxygen is present in water, but oxygen won't show its properties. Primarily at reacting stage, oxygen we are able to inhale it, and we can take it for breathing purpose. But oxygen, once if it combines with oxygen, the formed one is water. Are you able to inhale that water? No, it is impossible. Hydrogen in its individual state, it's a very energetic fuel. I mean, it acts as a high energetic fuel, but it is present in water. We are not using that water in its state as a fuel. So these are some of the properties that shows the differences between compounds and mixtures. And further, mixtures are of different combinations: solid and solid, solid and liquid, liquid and liquid, and liquid and gas, solid and gas. So gas and liquid, gas and solid. So different combinations of mixtures are also will study.